Yes, welcome to our new lesson of alkenes. And in lesson 1, I will be introducing to you what alkenes are. In O level, you must have hinted on what alkenes are, and because of that, this introduction won't be so long, but we shall mention a few things that are important to our further study. Now, what are alkenes? How do you identify that this is an alkene? Alkenes are hydrocarbons that contain at least one carbon-to-carbon double bond within the carbon chain. Meaning that the only way that we can identify that this is an alkene is the presence of a carbon-to-carbon double bond. So the carbon-to-carbon double bond becomes the functional group of this homologous series of alkenes. So we are saying that in our introduction, it is very important to remind you that these are hydrocarbons that contain at least means one or more, contain at least one double bond within the carbon chain. Now that means that their functional group is therefore the carbon to carbon double bond. Carbon to carbon double bond. If you wanted the formula, then we would normally say carbon double bond and then these other bonds here. This is the structure of the carbon to carbon double bond. General formula, they are represented by the general formula, okay, the general formula is CnH2n. Remember, we saw this in O level, and you can put it to test and rate any formula, any molecular formula of an alkene. So where n is number of carbon atoms, Quickly, let us look at how we can name these organic compounds. What we call nomenclature of alkenes. Nomenclature of alkenes. Quickly, you see, the naming of alkenes gives us the ideas on how to name other organic compounds. So these ones we may not really delay so much on them, but we shall see a few things that we need to incorporate in already what we know. So we are saying that in the nomenclature of alkenes, we use the rules that we suggested for alkenes, and therefore we shall be seeing things like choose the longest continuous chain, indicate the position of this. So let's see. Rule number 1, we shall see that the first four names, the first four members have standard names standard names, similar to those of alkenes. However, the suffix ane of the corresponding alkane, these are supposed to be the first three, sorry. The suffix ane of the corresponding alkane is substituted with the suffix ene to give the name of the alkane, alkene. So that means the names of the alkenes come from the names of the alkanes. However, the ending or the suffix ane of the alkane is changed to ane to give the name of the alkene. We are saying the first three members. In alkenes, we say the first four members. Why? Because alkenes must have at least a double bond. That means there is no alkene with one carbon atom. So as we have methane for alkenes, there is no corresponding member of one carbon atom in alkenes. So we begin with the carbon atom number 2. Okay? So alkenes begin with carbon atom number 2. Let's see this. Let's see. So if I have number of carbon atoms, I can put that table here. I can put, if I have number of carbon atoms, and then the molecular formula, this is number of carbon atoms. I can put the molecular formula, and then I can put the structure formula. I can put the structure formula, and finally, I can put the name. I can put the name of the alkene. So if we said carbon atom number 1, we do not have such an alkene, because there must be at least a double bond between two carbon atoms. So when you go to carbon atom number 2, the molecular formula will be C2. Remember we said the general formula is CnH2n2. So C2H, how many are these supposed to be? Times 2. That should be 4. And so our structure formula, we must show a double bond between the two carbon atoms, and then we distribute the hydrogen atoms, one there, another one there. Remember, in whatever we do, every carbon atom must have 4 bonds around it. If you don't want to write it like that, you could actually simply just say H2 and keep quiet about the carbon-hydrogen bonds. However, the double bonds between the carbon atoms must be shown, because that's what makes it an alkene. If you don't want to write like this, you can write like that. And the name of the alkene. The corresponding name of an alkane with 2 carbon atoms is ethane. But we said the suffix ane is removed and substituted with letters ene. And so that gives us the name. So the name of this compound is going to be ethene. The name of the compound is going to be ethene. Let's quickly check to the third member, 3. Okay? 3, we shall have C3H. So according to the formula, we multiply N by 2. So this will be 6. So we arrange 3 carbon atoms and then introduce a double bond somewhere. Okay? Either here or here, whatever you want. So we put a double bond there, and the rest we put hydrogen atoms, ensuring that there are 6. So here, if we want 4 bonds, then 1, 2, 3, 4. So these are 3 hydrogen atoms. Here there are already 3 bonds, so we put 1 hydrogen atom, and then there are 2, so we put 2 hydrogen atoms. This is the structure of the alkene with 3 carbon atoms, but we shall write it in a more advanced way and say that the first carbon atom had 3 hydrogen atoms. The second carbon atom had 1 hydrogen atom. I can put it there and introduce a double bond, and then put the last one had, or the first one had 2 hydrogen atoms. Now, the corresponding name of an alkane with 3 carbon atoms would be propane. And so, we remove letters A and E and put letters E and E. And so the name would become propene. So that's the name of the corresponding alkane, and this is propene. So what are we doing? Substituting letters A and E with letters E and E, with what we already know from alkanes. Let's check out number 4. Number 4 will be C4H how many? Remember, we multiply by 2, the number of carbon atoms. So that makes them 8. This is 8. So we arrange 4 carbon atoms. We have 1, 2, 3, 4. Okay? So we introduce a double bond somewhere of our choice. If you put the double bond here, okay, someone else could put it there, and then you'll have C. Someone else could put it here. Those are the 2 possible arrangements of this. Now, if we arranged it like that, changing simply the position of the double bond, then you could put the hydrogen atoms. These are 4. How many do we have here? 3, so we need a 4th one. These are also 3, we need a 4th one. And then this. So that means if we are simply looking at arrangement of the double bonds, for this compound, there are 2 possible arrangements. One, having the double bond between the first 2 carbon atoms. This is the same as when you place them here. Then, there are those that are between the second and third carbon atom. So that means this compound here has what we call position isomers. This one has what we call position isomers. Let's write them and see. This one is CH3. The first one we wrote CH2, and then you can actually write this. It's okay. It's acceptable. You can write like that. And then the second one, from this molecular formula, there is a position isomer, and it is CH3. This time it is in the middle, making this compound symmetrical. Okay? Now, the names. Now, when you see that the structure formally written, there is a possible isomer of it, a possible position isomer of it, then it is very important that you name the position of the carbon atom to which the double bond is. Here, there is no possibility of positioning isomers, that even if I change this double bond, I put it here, it will be the same compound facing in the other direction. but changing this position, this gave us this one. So we are supposed to indicate the name, the position of the double bond. And in the process, we make sure that the double bond takes the lowest number possible. So that means numbering begins from the side that will give the double bond the lowest number possible. So that means that I don't number the longest continuous chain from this. I number from this side. Because when I number from this side, this carbon atom having the double bond is going to be number 3. But then someone coming from this side is going to be number 1. So the lowest number is the right name. So this, if it was an alkane, it would be called butane. It would be called butane. So we are going to remove letters ANE and put letters ENE. Okay? But because they are position isomers in the arrangement of that molecular formula, we shall fix in the position of the double bond. Okay? So, what are we going to say? This, we are going to number in such a way that we give this carbon, the double bond the lowest number possible. And so that means beginning from this side. Okay? For this, wherever side you begin from, this will be 1, 2, 3, 4. If you begin from this side, it will still be 1, 2, 3, 4. So that means the double bond is on position 2. But here the double bond is on position 1. So the name would be, it is from butane, okay? But before we say butene, we need to put the position of the double bond. And here the position is on carbon atom number 1. So but 1 in. Remember these rules that we separate numbers from words using dashes. And then here we have what we call but 2 in. We are separating numbers from words using dashes. These are rules that we generated in alkenes, and that's why I was saying the nomenclature of alkenes is very important. So what is the difference between these names and these? The difference is that this molecular formula has what we call a position isomers, so we need to be very sure which compound are we talking about. So but 1 in has the double bond at the end. But 2 in has the double bond in between. And when numbering, we make sure the double bond takes the lowest number possible. And that is the only difference that we have so far seen. This would continue even if you had 5. Even if you had 5 carbon atoms, you would have C5, H10, this is molecular formula. So structure formula, you'd have C3, CH2, CH, this is 1, 2, 3, 4. I can put here 2, CH2. Then someone else would shift this to the next, and you have C3, CH2, CH double bond, CH3. So you can realize that those are different position isomers, and they could get different names. How could we name the first one? It is at the first carbon atom. First carbon atom, so this one would be pent. Remember the name would be pentane if it was an alkane because of 5 carbon atoms. But then we need to locate the position of the double bond, which is number 1. So pent 1N. This is what shows that it's an alkene. Then this one should be pent 2N. This is what shows that it's an alkene, but the double bond is on position 2 of the carbon atoms. Here the double bond is on position 1 of the double bond. Now when we come back for the next lesson, we shall be seeing how we name those that are branched. See you there.